Europa has been lying to us. For decades, we looked at this moon and saw a smooth, frozen ball of ice orbiting Jupiter. Quiet, dead, forgettable. Just another distant world in the cold outskirts of the solar system. Nothing that should matter. But what if that picture was never the truth? Because now, the most advanced eye in human history, the James Webb Space Telescope, has taken a closer look at Europa. And what it's revealing is not just surprising, it's unsettling. Something is happening beneath that ice. Something warm, something active, something that should not exist on a moon this small, this cold, this far from the sun. And for the first time, we're not guessing anymore. We're starting to see it. Europa is one of the 4 giant moons discovered around Jupiter by Galileo Galilei in 1610. From a distance, it looks almost peaceful. A cracked white sphere about 3,100 kilometers wide, slightly smaller than Earth's moon. Its surface is ice. Not smooth ice, but fractured, streaked with reddish-brown lines that stretch for thousands of kilometers, like scars across a frozen face. For a long time, scientists assumed that was the end of the story. Just ice, just rock, just another dead world. But that assumption started to break in the late 1990s when NASA's Galileo spacecraft detected something strange in Jupiter's magnetic field near Europa. The data suggested a large, electrically conductive layer beneath the surface. The only thing that made sense: salt water, a global ocean. Not a lake, not a pocket. An entire ocean hidden beneath the ice, possibly holding more water than all of Earth's oceans combined, sealed under a shell that could be 10 to 30 kilometers thick. And just like that, Europa stopped being boring. Because where there is liquid water, there is at least the possibility of life. Not proof, not certainty, just a door left slightly open. For years, that's all we had. A theory, a frozen mystery we couldn't touch, couldn't drill into, couldn't confirm. We were standing outside a locked room, pressing our faces against the glass, hoping something would move inside. Then came the James Webb Space Telescope. It didn't need to land. It didn't need to drill. It just needed to look, harder than anything had ever looked before. Using its near-infrared spectrograph, Webb began reading the chemical fingerprints on Europa's surface from more than 600 million kilometers away. And in 2023, something unusual appeared: carbon dioxide. Now that might sound ordinary, but on Europa, it changes everything. Because carbon dioxide can come from 2 places. It can arrive from space through impacts and radiation, or it can come from below the ice, from the ocean itself, pushed upward through cracks and refrozen onto the surface. And Webb didn't just find carbon dioxide, it found it concentrated in one specific region, Terra Regio, a geologically young, broken, chaotic area where the ice looks disrupted, almost like something from below forced its way upward. The pattern mattered more than the molecule. Because this wasn't random dust from space. It was organized, localized, intentional in its distribution, as if the surface was being fed from underneath. A team led by scientists at NASA Goddard Space Flight Center confirmed the interpretation. The carbon likely originated in the ocean beneath the ice. And that changes everything. Because carbon is not just another element. It is the backbone of all known life. For the first time, we had evidence that Europa's hidden ocean isn't just water. It's chemically active. It's communicating with the surface. And maybe, just maybe, it has the ingredients needed for life. But Webb wasn't finished. Scientists also searched for something else. Water plumes, jets of vapor shooting out of the surface, like geysers. Earlier hints from the Hubble Space Telescope suggested they might exist. But Webb's more sensitive instruments told a different story. No large, continuous plumes were seen. And strangely, that's actually important, because it means Europa is not constantly erupting like Enceladus. Instead, if plumes exist at all, they are likely rare, sporadic, triggered only when tidal stress builds up enough to crack the ice. Which brings us to the real engine inside this world. Europa should be frozen solid. At Jupiter's distance, sunlight is almost meaningless. Surface temperatures drop to around -160 degrees Celsius. Nothing should be moving. Nothing should be warm. And yet, something is heating the inside. The answer is gravity. Europa's orbit around Jupiter isn't perfectly circular. It wobbles slightly because of gravitational interactions with other moons like Io and Ganymede. That wobble creates tidal flexing. Jupiter's gravity stretches and squeezes Europa constantly, like kneading dough. That motion generates heat. This process, called tidal heating, is powerful enough to keep a massive subsurface ocean liquid for billions of years. Think about that. A moon being kneaded by a planet so large that it could fit more than 1,000 Earths inside it. And that squeezing is what keeps an ocean alive beneath the ice. That ocean may be 60 to 150 kilometers deep. At the bottom sits a rocky seafloor, where water meets stone. And that matters more than anything else. Because on Earth, life may have begun at exactly those kinds of interfaces, where heated water interacts with rock, releasing minerals and energy. If Europa has hydrothermal vents at its ocean floor, then it has energy. If it has carbon, it has chemistry. If it has water, it has solvent. That's 3 of the 4 ingredients for life as we understand it. The 4th is time. And Europa has had billions of years. Still, we must be careful. None of this proves life exists there, not even close. What we have is potential, a narrowing of possibilities, a tightening of the scientific net. And Webb also revealed something else important: ambiguous hints of organic molecules. Not confirmed, not clearly identified, but present in the spectral noise. Not a discovery, a clue. Humanity is now preparing to get closer than ever. In 2024, Europa Clipper launched under NASA to study Europa through dozens of close flybys. It won't land, but it will repeatedly sweep past the Moon, scanning the ice, mapping the surface, and sampling particles drifting into space. Its SUDA instrument will taste tiny grains of ejected surface material, while Reason will use radar to look deep through the ice, searching for hidden lakes, plumes, and signs of ocean material rising upward. At the same time, ESA's JUICE mission will independently study the same system, helping confirm and cross-check findings. Europa exists in extreme conditions shaped by Jupiter's radiation, which requires heavy shielding for every close pass. Yet that same radiation may also support chemistry below the surface. When Clipper arrives around 2030, it will test whether Europa's surface is truly connected to its ocean, and possibly open the door to life.